All right, Tuesday in class, I am going to do an assessment with you guys to see how well you can create a graph, create a scatter plot, and how well you can use that data to find the line of best fit and then make a prediction. So here's just a little video. This is the same question I gave you guys today in class, but I'm just going to walk you back through it so that you know exactly what to expect tomorrow on this assessment. It's going to count as a test grade. And so here's the problem. So let's say I asked you to graph, and I could actually probably, let me fix this real quick. The question mark. It says graph the data below and find the line of best fit. How long do you think it would take to mow a yard with an area of 1,000 square feet? All right, I'm not doing the what ifs. I'm not doing any of that kind of stuff. It's the same lawnmower used every time. You know, we're not doing all that kind of stuff. We're just basing our answer solely on the data that we have in front of us, okay? And so if I'm telling you, I've got these different measurements of yards. So I've got a yard that's 400 square feet, a yard that's 500 square feet, a yard that's 600 square feet, and a yard that's 700 square feet. And these are the different times and minutes that it takes to mow the yard. So with this data, you would first begin by creating a scatter plot. So here's a coordinate plane. Everything here is going to be in the first quadrant because the size of our yard, it's all positive numbers, and the time to mow the yard is all positive numbers. We don't have negative time. We don't have negative sizes. So everything's going to be in the first quadrant. The numbers start at 0. You always start here at the center at the origin. And for the x-axis, it increases going out. The y-axis is increasing going up. Excuse me. So for this example, the size of the yard, you can see that's here on the x-axis. So that's going to be our x. And the time to mow the yard, that's going up on the y-axis. That is going to be our y. And I did that y backwards. Sorry. I'm having to write with my mouse. My tablet broke. So, all right, so that's the time to mow the yard in minutes is y. What I want you to notice that I have a title here on the graph. Notice that I have labeled the x-axis and I have labeled the y-axis, even with the unit. And that's important because when it says time to mow, we talk about hours, days, seconds. What are you talking about here? And then size of the yard. There's a difference. Is it square yards, is it square millimeters, square inches? What is that? So you need to make sure you put the dimensions, the unit that's given. So then I've got these on here. I've also got a correct scale. Now, you don't have to go by 100s if you're doing this yourself. It all depends on the number of lines you have. Of course, if you could go by 50s or something, that might be a little bit better as far as, you know, the more accurate you can get, the smaller you can use. That's always the best option. But here I didn't have enough room, so I went by 100s. For the y-axis for the time, I went by 10s. Again, if I could have gone by 5s, if I had enough room, that probably would have been better. But I didn't really have enough room, so I had to go by 10s. But again, notice you start down here at 0, and I went in intervals of 10, and I stopped at 70 because my lowest or my highest number is 64. So I need to make sure I include all of my numbers. So then I plotted my points. I have 400 square feet is 40 minutes, 500 square feet is 52 minutes, 600 square feet is 57 minutes, and 700 square feet is 64 minutes. So now I've got everything plotted. This is my scatter plot. So then I wanted you to come up with a line of best fit. So once you have this, you're going to put an oval. And again, I apologize because I'm having to draw this with the mouse. So I'm going to draw an oval around the points. Not too bad. Did pretty good there. And then I'm going to draw a line that goes through the middle of the oval. Again, I did pretty decent. Once you have that, and tomorrow when you do this assessment, tomorrow when you do this assessment, you're going to have many, many more points. You're not going to just have 4. So you're going to have a bigger oval, bigger area. You're going to have more points involved here. But you want to pick 2 points that are on the line. If you don't have 2 points that are on the line, pick 2 points that are very close to the line. So for me, it works out nicely because I have this one here, and this one is, I'm just going to draw a little arrow here. This one is 400, 40. And then I'm going to use this one here, which is 600, 57. All right, so let me pause this and I'm going to work this out and then I'm going to come back and show you. Okay. Okay, so we have the points 400, 40 and 600, 57 that we identified on the graph that the line of best fit goes through. And so finding the difference of my y's, 57 minus 40, I got 17. And then my difference of my x's, 600 minus 400, which is 200, I can find the slope. And I can plug it into the point slope formula. Because once it's in the point slope formula, we can simplify it and it's in slope intercept form. So I plug it in, and I'm going to use the point 400, 40. You could have used this point if you wanted, but this is just the point that I'm going to use. All right, so I plugged it in point slope formula, which is y minus y1 equals m times x minus x1. So my x1 is 400 and my y1 is 40. So y minus 40 equals 17 over 200 times x minus 400. Okay, now I'm going to go through the process of simplifying it. Again, I apologize that I can't write on here, so it would probably look a little bit easier. 17 over 200 times x is just 1700 over 200 times x. There's nothing you can do with that. But 17 over 200 times 400, if you multiply all this out, you end up with 6,800, because 17 times 400 is 6,800 over 200, and all of that simplifies to 34, which is pretty nice because it works out pretty easy to work with in that case. So I'm left with y minus 40 equals 17 over 200x minus 34. I add 40 to both sides, so my equation, and this is my line of best fit, is y equals 17 over 200 times x plus 6, where x is the size of the yard and y is the time that it takes to mow the yard. You can go back and look. X is the size of the yard, y is the time that it takes to mow the yard. So now we have this in point slope formula, okay? So with this equation, I can now predict, based on the size of the yard in square feet, I can figure out the time in minutes it would take to mow that yard. So now the last question was, how long would it take to mow a yard that is 1,000 square feet? So again, I have that formula, and the x represents the size of the yard in square feet. So I'm going to replace x here with 1,000. So that's all that I did here. This was your equation for the line of best fit. And I'm going to plug in 1,000 there. So when I do that, and again, this works out pretty nicely, 17 over 200 times 1,000 equals 85. And then I add the 6 to it, and I get 91. So it would take me 91 minutes to mow a yard that's 1,000 square feet.